Hello everyone. Am I audible to you guys?
Yes, ma'am. Loud and clear.
Okay. So, did anybody have any doubt from the previous section or should we start the new section?
This is the first session I'm just joining.
Okay. It's okay. Okay, so first, as we have decided in the last session, we will do a small overview of what sir have taught you in the last 1 week, and then we will start with the questionnaire section. Okay. So, little outline of what you guys have already studied is about the significance of the maintenance and repair thing and fundamentals of corrosion. And then you might have studied about different type of corrosion, mainly carbonation induced and chloride induced corrosion. And then in week 2, you might have studied about different type of steel reinforcement and precaution to be taken. And the last thing you might have studied is corrosion in pre-stress concrete, right? So firstly, in week 1, you might have studied about the corrosion in steel and concrete. So, as we all know, concrete is mostly alkaline in media. So, in alkaline media, we can see at higher pH, steel is present in passivity. Means steel have a strong passive layer formed around it, and steel have a strong passive layer formed around it when it's present in the high pH area. And because of that, our steel is protected. And the normal corrosion cell, how corrosion is happening is on the steel surface itself, it's forming an anode and a cathode. And there is an ionic conduction current flow through from anode to cathodes. This iron is converting to iron oxides, iron is converting to iron ions. This I and releasing some electrons. And these electrons, when consumed by the oxygen present in the electrolyte, they will convert into OH negative ions, which are formed on the cathode part. So iron from the anode part is being consumed, and it is forming a products on this on the junction of anode and cathodes, which we call as rust products. Next thing, so this is a clear to everyone, right? Okay. So the next thing is about the different type of corrosion present in our concrete system. We have two type of corrosion, uniform corrosion and localized corrosion. When chlorides from the external environment or chlorides present in the concrete itself, when they react with these Fe2 positive ions, what is happening? They are consuming all the iron and they are forming chlorides, Fe chlorides, iron chlorides. And because of that, at the point at which they are acting, these chlorides are acting, they are causing a pit. The iron from that particular point will be consumed and causing a localized type of corrosion. Second type of corrosion is uniform corrosion. Uniform corrosion happens because of carbonation. When CO2 reacts with the hydroxide, it is forming calcium carbonate. And because of this formation of calcium carbonate, our pH is reducing below 9 and 10. So at this point, our below 7, 8, like this point. At this point, what is happening? Our steel is present in the corrosion area. So at this point, this passive layers start deteriorating, and the type of corrosion we will see on the steel surface will be uniform type of corrosion. Okay. So this is the basic overview of the corrosion of steel in concrete. The other thing is the how to improve this corrosion chloride threshold. How this chloride threshold can be improved is for most of this most simple part of this is using corrosion inhibitors. So what corrosion inhibitors are doing, they are reacting with the passive layer and forming a strong passivity around the steel surface. Okay, so this is what you might have studied in week 1. Does anybody have any doubt in this thing? You can ask.
Just one thing is, what is the inhibitors?
Inhibitors are simple chemicals which we are adding into concrete. Like you might have studied about superplasticizer, right? Superplasticizer are the
Yes.
chemicals we are adding to enhance the property of concrete. Same way, we are adding some chemicals which will enhance the passive layer. So they are called as corrosion inhibitors.
Understood. Understood. Can you give me an example for that inhibitor?
So inhibitors, there are two types of inhibitors mainly, organic and inorganic. In inorganic, we have nitrates, sodium nitrate, calcium nitrate, or in organic, we have amines or carboxylic acids. So they are mostly type of inhibitors, chemicals which we are using. Okay.
Understood.
Okay. So this is overview of week 1. So I will go to the week 2 part. In week 2, you might have studied about different type of steels. Firstly, we have the bare steel, and then we have the HYSD steel, and we have pre-stressed concrete steel bars, and we have galvanized rebars. Galvanized steel bar mainly zinc coated or simply zinc rebars. Then we have different type of coated rebars. We have epoxy coated rebars. We have corrosion resistance rebars, and then we have non-metallic rebars. Non-metallic rebars are mostly FRP rebars, fiber reinforced rebars. Okay, so these are the different type of rebars you might have studied and how they are being formed and what are the disadvantages and advantages of each type of rebar. And other thing what you have studied in week 2 is the TM ring test. So in tempered martenstein rebars, we have two we have a cover of temper martenstein and we have the inside core of ferrite pelloid. So mostly this inner core is for the strength of the rebars, and this outer core it prevents the rebar from getting attacked from the outer chemicals and all. So you might have studied about this thing, how this test is done. Generally what we are using a nitrile solution, and we will pour that solution over the surface of our uh, pour that solution over the surface, and then we will wait for 15 to 20 minutes. After 15 to 20 minutes, we will see a clear ring of temper martenstein. If we are not seeing that ring, then we can say that our rebar is not of a good quality rebar. If we are having a clear ring outside, then we can say that it is a good quality rebar. So this test is mostly done to check the quality of our rebar. Huh. The last thing which you have studied is about the corrosion in pre-stressed rebars. So how exactly is pre-stressed rebar is? We have one king wire and it is covered by 6 outer wires. So we call them as strands. So we have 7 strand rebar that is called as pre-stressed rebar. So what main issue with pre-stressed rebars is when corrosion takes place, some corrosion products are forming. In normal rebar, what is happening? These corrosion products are forming around steel surface, and they are causing expansion in the concrete, and we can see the cracking. But when it comes to pre-stressed rebars, these corrosion products are taking space inside the strand parts, and because of that, you can't see the cracking. And because of this, we can say that the pre-stress corrosion is a catastrophic type of corrosion. Okay, this was what you have studied in week 2. Any doubt you have?
In if this TM print test we can use for both the epoxy coating and the coated steel also we can test.
No. TM ring test is mainly for temper martenstein rebar only. TMT rebar only.
TMT bar only.
Yeah.
That galvanized and that for that steel also we cannot use.
No. Only for TM ring. Sorry. TMT ring. Yeah.
Clear.
Everything is clear. Can we go to the questions for this week? So we will start with the questionnaire session for today. Somebody have a doubt? Tushar, you raised your hand. You have any doubt? You can um, you can send your doubt in chat box if you want.
Hello.
Yes, Tushar.
Ma'am, as it was mentioned in one of the slides that as per ASTM 775, a comparison was made as per ASTM 775 and IS 13620 regarding the coating thickness of this epoxy coating thickness.
Yeah.
So ASTM was using around 177 micrometers of thickness, and our Indian standards we are using 100 micrometers of thickness.
Yeah.
So after using 100 micrometers of thickness, we are only able to provide 120 degree of bending only for shear
Yeah.
stress. So why can't we go for why can't we reach to the level of ASTM thickness coating so that we can also increase our bend angle without the cracking in epoxy coating?
See,
Because
even if you are increasing the thickness of the epoxy coated rebar, okay, you can improve the bending quality. But
yes,
in if we see our Indian scenario, we can't ensure a proper transportation of these kind of rebars. These epoxy
okay,
coated rebars, we have many defects. It's not just about the bending thing. When we are
mm,
transporting it, there are chances that
mm,
scratch will be formed, and because of those
yes,
scratches, this coating will be disturbed, right?
yes,
So that's why epoxy coated rebars is like we should avoid as much as possible, because we can't,
yes, yes,
even if we are giving 170 mm coating
mm,
thickness, we can't ensure that
mm,
our coating is uniform throughout the rebar, right?
throughout the river. Else Ceres told after once we can bend the rebar and then we can give the coating, but
Coating,
it
yeah,
will be a
but
very tedious process.
yeah, we can't adopt this thing on every construction site.
Yes, 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 yes. Okay, ma'am, okay.
Shall we start with the question section? Can you mute yourself, Tushar? So this is the first question. Consider that C1 and C2 are the cross section of two concrete prism specimen having same diffusion coefficient exposed to 3.5% NaCl solution from the top. So we have two type of rebars. One is TMT rebars, and then we have pre-stressed rebar, 7-wire strand. Okay, and both have the similar condition, 3.5% NaCl solution we are using for TMT rebar as well as pre-stressed rebar, and we have a same cover depth. So, if the chloride threshold value of the TMT rebar and the pre-stressing strands are same, Which of the following are the possible phenomena that you would expect? C1 would be the second to show visible crack. C2 would be the first to show visible crack. C1 and C2 corrode simultaneously, and C1 will show visible cracks before C2, or C1 and C2 corrode simultaneously, and C2 show visible cracks before C1. Any guesses for the answers? We have seen that C1 is normal rebar and C2 is pre-stressing rebar, right? We are saying that in C2, when rebar start corroding, the corrosion products is around the rebar, and it won't show visible cracks before normal reinforcing bar, before TMT rebars. So based on that aspect, what do you think, which option would be correct?
It should be C.
C1
C1
and
and
C2.
C2 corrode simultaneously. C1 will show visible cracks before C2.
Okay. So yeah, as we have studied, no, C2, C1 will show cracks before C2, right? Okay, it's clear to everyone, right? We can go to next question. So the next question is the mapping of ASTM C876 half cell potential measurements provide probability of corrosion in different location, rate of corrosion, or both A and B. So on sites, normally we do half cell potential test. What we are doing, we are just checking the potential from the rebar, and based on our potential value, more the negative potential value, we are saying more is the probability of corrosion. So based on the half cell potential measurements, what we can tell?
Ma'am, can you just explain this procedure once, please?
Okay, so in half cell potential,
ASTM.
we are taking a connection through our rebar, and we are through rebar we are doing connection. We use three electrode system. We have reference electrode, and working electrode will be our rebar, and then we can use uh, connecting these two rebars, reference electrode and working electrode. We will connect these two, and we will measure the potential difference. Normally, our reference electrode will have a particular potential. So based on that, we will get the potential difference value. So these potential difference value, we are saying that if it is more negative, minus 400, minus 500 volt, it is coming, then we are telling that there are chances of more corrosion. So this is the most basic test we are doing on site to test the corrosion negative. So based on that, anybody want to guess what can be the answer? Answer is A. From HCP test, we can only get the probability of corrosion, but we won't get the rate of corrosion. For rate of corrosion, we need to do other tests, some EIS. I think you will study all these tests afterwards. EIS tests, LPR test, and many other electrochemical tests. The basic test we are doing on site HCP test will only tell about the probability of corrosion. We are just saying more the negative HCP value, more will be the corrosion. Okay, is it clear? Can we go to next question then?
Yes, ma'am.
So next question is the beam shown in figure is located in a coastal region where the relative humidity is more than 80%. After visual inspection, it was suggested to patch the area with repair mortar and paint the surface without any additional work. So what is your inference about the suggested strategy? The strategy is correct. Like if we can just patch repair and paint the surface, The root cause of the problem is not identified and addressed appropriately. No tests need to be conducted before selecting a repair strategy. Only visual inspection is sufficient, and redundancy is zero in this case. Question is clear first. Okay, so what question is telling? We have a corroded area where our relative humidity is more than 80%. Okay, then what we are doing, we are just, we saw the place, we patched, repaired it, and then we painted it. Do you think it is the right way to do the repair?
No, ma'am. No.
So we can say that this strategy which is suggested is incorrect. So this option is completely wrong. Second is
Wrong.
root cause of the problem is not identified and addressed appropriately. So this is right.
That is right.
Next is no test need to be conducted before selecting a repair strategy. Only visual inspection is sufficient. This is also wrong. With visual inspection, we need to do some tests. We need to get to know what is the exact root cause of the problem. And until we know the root cause of problem, we should not go for just patch repair. So this option is also wrong. Redundancy is zero in this case.
What is redundancy?
Redundancies means um say um, uh, repair like multiple repair. We don't need to do multiple repair in this case. But if we are doing patch repair simply, there are chances we have to do it
Repetition will come. Yes.
yes.
Ma'am, is it related to the redundancy of joints which we study in structures?
Sorry, can you repeat?
Is it related with somewhat with the redundant structures, redundancy in joints which we study in structures?
No. That won't come here. It's just simple. We'll say that multiple repairs thing. Statistically, redundancy is
Okay.
zero, not
Okay.
structure. So the
Okay.
answer is B. The root cause of problem is not identified and addressed appropriately. Is it clear? Can we go to next question then?
Yes.
Yes.
Match the following. Linear polarization resistant, ASTM C876, guard ring test, digital image correlation. And then we have option corrosion rate, stress strain behavior of corroded rebar, and chloride threshold, and probability of corrosion. Any guesses? Or any
It
problem
should
with
be
the
C or
question?
D. No,
Okay.
we actually don't know regarding the tests and all.
Okay.
With the previous question, I would say like it is C or D. Only we know this probability of corrosion. ASTM
ASTM
C876.
C876 will give probability of corrosion.
So
So based on this, we
so
are
it is like C or D.
okay. So linear polarization resistance is the type of test which we are doing to get the chloride threshold value. Oh, sorry, corrosion rate or chloride threshold value. See, these all are different type of tests which we are doing on site. LPR is mostly test which is done on site as well as in lab also. So you're telling ASTM C876 is the test done to get the probability of corrosion is fine. So we are telling C or D out of C or D. Then first is LPR test. LPR is test is normally done to get the corrosion rate or chloride threshold according to C and D, right? And then we have guard ring test. Guard ring test is done. Just a minute, with lab people. I will admit other students. Okay. So, we are telling ASTM we are doing for getting probability of corrosion and linear polarization resistance. Basically, this test is what we are doing. We are applying voltage and we are measuring current. So, based on this test, we will get the chloride threshold value. Chloride threshold value you might have studied the maximum chloride content which is required to initiate the corrosion. So this is a lab test, LPR test. I think you will study further, and this is used to get the chloride threshold value. And next is C, guard ring test. Guard ring test is another type of test which we are doing in the lab to get the corrosion rate. About the procedure of these all type of test, I think you will study further. And next is digital image correlation test, DIC. DIC test is mostly done to get the stress strain behavior only. So I think you might have not studied about these things. So we'll directly go to the answer. Answer is D. LPR to get the chloride threshold value. ASTM to get the probability. Guarding test for the corrosion rate. And DIC for getting the stress strain behavior of the corroded rebars. Okay. Next question.
Yeah.
To prevent corrosion, polymer modified mortar was used to protect the embedded galvanized steel rebar. What is the redundancy of adopted strategy? Here you are using that redundancy, the one you were telling in structure you get now. To prevent corrosion, polymer modified mortar was used. First, you know polymer modified mortar, right? We are adding polymers in the mortar. Simple.
It's A option.
C option. Okay. How? You're telling two.
How will we identify the redundancy and how many times we'll have to do this repairs? How will we identify? Because it can be repetitive, right?
Yeah, it can be
Because since already the galvanized steel bar is corroded in the sense the galvanized coating has gone. So again, if we do some plaster modification and all, patchwork and all, still it is bound to happen.
it's bound to
So
happen.
how
That's
can
why
we
we
say
are.
these many?
Sorry.
How we can say how many number of times it can happen?
See, wait. In case of galvanized rebars, we are telling our coating is getting removed, right? When corrosion is happening. So, if we are adding polymer modified mortar, we are tend to this polymers will react with the zinc ions and they are forming another type of protective layer over the steel bar. In case of polymer modified rebar, these polymers are behaving as another type of coating over the steel bar, over the galvanized steel bar. And the other thing is our mortar. The mortar is all will have higher pH as compared to the mortar present in the other area, and this will cause this mortar will have a better pH, and this will cause another type of passivation to the steel bar. So we are having two type of
Understood.
thing.
Understood.
Yeah. Durable repair material. A repair material mortar is durable, more durable. And second thing is this polymer is modifying our steel surface. So based on this, we will have one. The answer would be the one redundancy. It's okay.
How would how did we come to this derivation of one?
That complete derivation I don't have for now. This thing.
In the previous slide, you said like how many number of repairs is required is bound to happen. That is
Yeah,
the redundancy number. So
yeah.
if you are doing this repair, then there should not be any sort of repetition that should happen, right?
Repetition is not there, but this first one-time repair you have to do, no?
Okay.
So we'll go to the next question then. Some concrete columns made with M50 grade concrete of an industrial building were found inadequate to carry the intended design load. The columns need to be repaired by enlarging their cross section, which would be the recommended repair material. A material with higher modulus of elasticity than substrate, with lower creep and shrinkage, or similar modulus of elasticity with lower creep and shrinkage, or lower modulus of elasticity with lower creep and shrinkage. What can be the answer? See, one thing whenever we are adding something over our substrate material, we have to make sure that there is a strong bond between uh, substrate layer and the top surface layer. So to ensure that there is a perfect bonding between those both of them, we need to have lower creep and shrinkage. That our repair material should not have a more shrinkage, otherwise it will debond from the substrate, right? Second thing is the modulus of elasticity. What do you think the modulus of elasticity should be? Should be higher than the substrate, similar, or lower?
It should be similar, man.
Yeah, right.
Otherwise, bonding might be an issue.
Exactly. So the modulus of elasticity from substrate as well as the repair material should be similar, and creep and shrinkage should be the low. Is this clear? Shall we go to next question?
Yes, ma'am.
Okay. ASTM G109 test method for assessing the microcell corrosion between multiple rebars can be solely used for corrosion assessment of steel in highly resistive concrete system. True or false? Any guesses? ASTM G109 test setup you have seen in inhibitors thing you might have read about it or not yet you have read it. So in this test method, what we are doing, we are making a concrete with three rebars, one at the top and two at the bottom, and we are passing current through all these three rebars and we are passing current and we are calculating our potential through all these three rebars. So, do you think it can be only used for steel in highly resistive concrete system, or it can be used for other system as well? You might have not read about it, right? It's a false one. So what we are just doing, we are calculating potential difference between three rebars. So it doesn't have anything to do with the concrete system. So it can be used for the highly resistive system as well as low resistive system. So that's why the answer is false. Okay, can we go to the next question then?
Yes, ma'am.
So arrange the steps which shall be adopted for surface repair in the correct order. We have different steps, 9 steps, and you have to arrange them in the correct order. Whenever you go for a site visit, sorry, repair strategy, what should be the first thing you need to you need to do? Undercutting of reinforcement. Nobody saying anything?
root cause analysis.
Okay, what should be the first step you need to do?
D.
D, root cause analysis, fine. Second step, okay, you got the root cause, you did some visual inspection, you did some testing, and you got the root cause analysis. Then second thing, what you will do?
Then it is H.
H, you
Repair
will choose
strategy.
a
Choosing the
repair
repair
strategy.
strategy.
Right. Next thing,
Then general removal
general
is
removal. Okay.
general
E.
removal. Followed
Sorry.
by conditioning the surface.
Touch.
Conditioning the
Okay.
surface should be the next one.
Okay. Next, conditioning the surface.
Choosing the repair
Okay.
strategy.
Choosing choosing the repair strategy. Okay. Uh, That was the second step you were saying, right? Okay, the first step is we are telling root cause analysis. Second, you are telling choosing the repair strategy. Third, we are doing what? Conditioning the surface, right? That you told.
Yes.
No, for journal removal, then conditioning. Okay, next.
Yeah, what is this layout for repair?
Where you have to prepare a layout for the repair. What you will do at what. See, first thing you are doing a root cause analysis. That is clear. Then we are choosing the repair strategy. Fine. Third thing is you are choosing the repair strategy, but you didn't choose the material for the repair, right? Repair strategy. After that, you have to choose the material also. So next will come as the repair material selection. I think that's clear, right?
Yes, ma'am.
Right. So you have seen the site, you have done the root cause analysis, you have done chosen the repair strategy, you have chosen the material to be used as for the repair. Next is you will do a layout of repair. What step to be followed at complete layout. You will do the marking and all. That is layout for the repair. At what point you have to do repair and how much you have to do completely thing. That is layout for the repair. And after everything is done, then you will start the repair thing. So for the repair thing, then all the steps will come. Journal removal, and after journal removal, what you are doing? Journal removal means you are removing the mortar part. After removing the mortar part, what you will do? You will do the undercutting of reinforcement. Why we are doing undercutting of the reinforcement? Because if our rebar is corroded, before doing any patch repair, we should clean the rebar. We should make sure that it's not corroding as fast as it was corroding before. So that's why we do the undercutting or reinforcement so that undercutting of reinforcement, and after that we will do the conditioning of the surface. This conditioning of surface is not the surface of the mortar, it is the surface of the rebar. And when conditioning is done, then we will apply the bonding agent between our older mortar and new mortar, and then lastly we will apply the repair material. Are the steps clear? Doubt in any step, you are not getting what exactly it is?
We can proceed, ma'am.
Okay. So these are the steps as we have seen. I hope it's clear to you all. We will go to the next question. Why is undercutting of rebar significant in repairs work? We have already discussed this thing. Can anybody answer this question then? Enhancing the bonding between substrate and repair material, provides uniform electrochemical environment around the reinforcement. Only B, both A and B.
Both A and B, ma'am.
Okay. Answer is correct. Both A and B. We are enhancing the bonding as well as we are making sure that our rebar is clean enough so that it will provide the uh, correct environment for the reinforcement. So these are the questions which for today's session. Does anybody have any doubt? They can ask me now.
Ma'am, there was one question in the first assignment given to us.
Okay.
It was the chlorination aspect. That was a query, and in which it was asked like if the entire outer surface is closely packed, then if there is presence of moisture inside the moisture and traces of air inside the system, can the corrosion occur again? That was the question asked. So what will be the answer for that? Because from the exterior it is completely corded off. Then it should not happen. No?
See, what we tell that two main important things for corrosion to take place is moisture and oxygen, right? So if moisture and oxygen is already present inside, there are chances of corrosion. It won't be a like we'll say it won't be any chloride induced or carbonation induced corrosion. It won't be that type of corrosion, but that rust layer will be forming. The passive film, it will convert to rust layer slowly. You understand the difference between this
Yes,
passive?
and it will come to a halt, right?
Yeah.
After some time, it will come to a halt. It will come to
It
a normalcy.
No. Corrosion is a continuous process. It won't come to halt, but it will take time to corrode. It won't be corroding like within a 10 years or 20 years. It will be 50 to 100 years. That will be a longer period. That won't affect much, but we won't say that corrosion is stopping.
Understood, ma'am. Thank you.
Anybody else have any question? Have any recommendation for me? Sorry, any feedback for me? What we can do to improve the session?
Ma'am, how will the question paper be? Like there is set like there is a test that is going to happen in the month of April. So can we get some sort of a mock question paper so that we can be prepared? Will that be an MCQ type or fill in the blanks kind of question pattern?
That question paper, I don't know. I think sir only set it. But I will ask if I get to know some previous year questions or something. I will share with you.
Yeah, fine, fine. Yeah.
That is an objective type, or it will be a conventional or like that.
I'm not sure. I think I can tell you this thing in next session only because I have not registered for it. So I will tell you by next session. Anything else you have? Sorry?
Ma'am, hi ma'am.
Huh?
For the examination, the centers for people who are staying in Chennai, can we take it up in IIT Madras, the center? Because it is shown Andhra Pradesh or somewhere.
Okay. Actually,
Is
this
there any option for that?
I'm not sure about examination, final examination. Uh, I will ask somebody and get to tell you all about it. Okay?
Okay.
You still have time to register for it,
One,
right?
yes, February 12th, I guess.
Okay, by next session, then I will tell you.
Yes, yes. One more suggestion. If it is going to be MCQ questions, right?
Hmm.
If you are going to discuss that, we can introduce some polling, maybe. So we
Introduce
can
some
just
what?
polling.
Polling. Okay. Okay.
So we can select what option that we think is good, and
Correct.
maybe
Okay.
you can also see how much percentage of them are choosing what,
Okay.
probably, and then if you can take it as a collective count, and then maybe you can give a feedback.
Okay. Fine.
So everyone will be that way. Everyone will be waiting to see if what we chose was the correct answer or not. Later, you will be also giving an explanation.
Okay.
So
Fine.
this way, everyone participates, and it's a win-win. That's my humble suggestion.
Fine. Make sure next time.
Thank you.
Is it okay? Then can we stop the class for today?
Good day, man.
Okay. Fine then. We'll see you guys next week.